Hi there, it's Colin, your Kaplan MCAT teacher. I just made this video for you about the unit circle. You don't have to watch it, but you can. I've been reading your emails, and some of you have been saying that trigonometry is a little bit difficult for you and you need to review it. I remember when I was in high school, I had this really nice teacher named Miss Roderick who taught us the unit circle really well, and it seemed like it made everything else in trigonometry a lot easier. So if you are a little rusty about the unit circle, I thought I would kind of remind you of how it works. In that way, maybe it will help you remember your sine and cosine values that you need to know for test day. So I hope you enjoy. So the unit circle is just a circle whose radius is 1. That's why we call it a unit circle. And so I'm just going to draw it right here. Hopefully this is not an ellipse. This is supposed to be a circle. And I'll draw like a reference line just to show that its radius is 1 from approximately the center of the circle. And I'm going to draw it straight over to the right. It's a horizontal line. And I'll say that right here, this line represents 0 degrees. 0 degrees. And again, this is a unit circle, so I'm going to say its length is 1 whatever. And the next thing I'll do is draw another line representing some different angle. So let's say this second line, I'll make it red, is drawn from the center right about, say, here. Let's say that's about 30 degrees between that red line and my original sort of reference black line. So I'll call this 30 degrees. Not 20, 30. There we go. The next thing we'll do is draw a third line to make a triangle out of the line that we just drew. So I'll draw a third line. Maybe I'll give it a different color like green. And see here now we've made a triangle. And you might think this is a random thing to do, but hopefully you'll see why we might do this. Notice we made a right triangle. The green represents the height of that triangle. The red we could call the hypotenuse of that triangle. And then the segment of the black line from the center of the circle to the green line, we could say that's the x value of that triangle, or that's the length of that triangle. Notice that if we solved for sine here, we could say, okay, sine of that angle, in this case 30 degrees, sine 30 should be equal to the green line divided by the red line. Because this is a right triangle, so we can say sine of the angle is opposite over the hypotenuse, the opposite being the green line, hypotenuse being the red line. Well, if it's a unit circle, every single radius is a 1 unit radius. So the red line is really just 1. So in this case, we could say, okay, sine of 30, so sine 30 is equal to the green line. And for any triangle I drew on this unit circle in this way, for any radius I drew, the same thing would happen. We'd create this triangle whose height is equal to the sine of the angle. So let me give you an example. I'll just draw another line. Let's say this is about 45 degrees. If I drew another green line corresponding to the height of like this hypothetical triangle I just made, it would look like this. Maybe I'll use a different color though. Let's use like blue. See that? In this case, I could say, okay, sine of 45 is equal to the blue line, again divided by the red line. But just like we said before, the red line is a radius, so is this red line, and so it's just really the blue line. So sine 45 is equal to the blue line. So every single time we draw a line at a different angle, the sine of that angle ends up being equal to the height. So if we had drawn like our original line just at 0 degrees, it was just right here, there was absolutely no angle between it and the black line, you would notice there'd be no height there. There'd be no height at all. And so sine of 0 is 0. Kind of derive that. Sine of 0 is 0. because there's 0 height. On the other hand, if we drew our red line straight up to the top like this, we'd see that we are all height. We're all height. And that's a 90-degree angle. So on the other extreme here, between 0 and 90, we can say, okay, sine 90 is equal to 1, because that's the radius of our unit circle. So from the unit circle, we can derive kind of y sine is the y, and y sine of 0 is 0, and y sine of 90 is 1. Notice that if we were on a Cartesian plane, though, we would say the bottom down here, that's negative. So I'll just give you some other kind of important values for sine. First, I'll go to 180. Notice again, sine 180, we have 0 height, just like before. We have no green line that we could draw, or no blue line that we could draw. And so we could say the same kind of easy solution occurs. We could say, okay, sine 180 is equal to 0 again. But we don't say that sine 270 is equal to 1 again. This is, let me draw 270 right here. Here's 270. We say this is negative 1, because if we were on a Cartesian plane, that would be in the bottom half of the plane, and so that would be negative zone right there. So we'd say sine 270 is equal to negative 1. Bingo. The other values I'd want you to know for the MCAT are sine 30 right here. If that one's not too bad, you should know that's 1/2. So right there, sine 30. And also sine 45. You should know that's, this one, it's harder for me to kind of draw, but that would be equal to the square root of 2 over 2. So I'll say 2 to the 0.5. That's a way I could type square root. If you raise something to the half, it's a square root. So that divided by 2. It would be way easier to kind of draw that on scratch paper though. And then there's one that I haven't actually drawn yet. There's one that I haven't actually drawn, and that's 60 degrees. Right here. And you should know that sine of 60 degrees is the square root of 3 over 3. Sorry, over 2. I meant to say the square root of 3 over 2. Square root of 3 over 2. And then in class, I mentioned that you should know a decimal for the irrational numbers. So I'm talking about sine of 45 and sine of 60. So you should know basically an approximation of what the square root of 2 over 2 is. The square root of 2 over 2, that's going to be 0.707. So you could say this right here, sine 45 is approximately 0.707, but like 0.7 would probably be totally fine on test day, 0.7 or 0.71. And then you should also know a decimal for the square root of 3 over 2. And that's going to be, it's approximately 0.866. But 0.85 or something similar would be probably perfectly fine on test day. Cosine, we could also use this sort of triangular functionality to figure out all the different cosine values if we like. So if I kind of just start deleting things, start from scratch a little bit. Cosine we'll find out corresponds to the x on the unit circle. So starting with my reference black line here, let's draw a red line, and we'll draw this red line again up to 30 degrees. And the cosine value, if we did the same thing with our triangle, let me draw this red line like a triangle. So there's my red radius line, and I'm just going to bring it down like this just so you see. So there's a segment left over of the black line. That segment right there. So that segment of the black line goes from here to here. So this value like this, that's the x value, that's what cosine corresponds to. And if I were to draw another red line, say up to 45 degrees, the same thing would occur. I'll draw another, how about I'll do a blue line this time. This x value from the center to the 45 is equal to cosine. So cosine 30, you can see, is the green line. Cosine 30 is more than cosine 45. Draw another red line up to, say, 60 degrees. So here's like cosine 60. I'll give it a magenta value. Cosine 60 is going to be smaller. And if I drew a 90-degree line, a 90-degree radius up to the top, well, in that case, there's no x. There's no x of this line from the center. So cosine of 0 has the greatest x value you can have. So cosine of 0 is 1. Whereas cosine 30 is going to be a smaller value. Well, it turns out, it corresponds exactly to sine. So cosine 30 is the second largest cosine that you have to memorize, which is the same as the second largest sine that you have to memorize. So cosine 30 is root 3 over 2, or I'll just write the decimal because that's easier here. And then sine and cosine of 45 are the same, because you have a triangle here with two sides that would be the same. So whether you're talking about the x or the y, whether you're talking about the horizontal value or the height, it's the same. So cosine 45 is equal to root 2 over 2, but I'll just kind of write the decimal, 0.707. Cosine 60 is just like sine of 30. And so that's 0.5 or 1/2. I like fractions. And then you see cosine 90. There's no x value for cosine 90, so cosine 90 is 0, just like sine 0 was 0. And you could also imagine we get the same thing at cosine 270. If we were down here at cosine 270, there's no horizontal distance from the center. There's no x. I can't draw any x line. So cosine 270 is also 0. And if you want to get a cosine -1, well, you want this black line to be facing the other way. So over here, we're in negative zone for cosine. So if I drew a radius here, well, that's 180 degrees. That's a half circle. So cosine 180 is equal to -1. And so if you know these values, if basically you know them for sine and know them for cosine, you're all set for testing. Because by the way, if you ever have to figure out tangent, tan x is just sine x divided by cosine x. So for instance, if you wanted to figure out what the tangent of 30 degrees is, you'd say, okay, well, the sine of 30 degrees is 1/2. So let me give you an example. Tan 30 is equal to sine 30 divided by cosine 30. And so sine of 30 is 1/2, so tan 30 is equal to 1/2 divided by cosine 30, which is 0.866 or so. Actually, that one would be easier to keep as a fraction, probably, and work with that, but it's hard for me to write the radical in text. But you could basically make an approximation here. I mean, you just drop the 2 to the bottom, so this would be 1 divided by 2 times 0.866, and you could estimate this. Now, one more thing I'll mention. I mean, this is pretty much everything you need to know for the unit circle. The only question you might have, I'm guessing you're having right now, is what about radians? So between degrees and radians, just know this simple kind of relationship. 2 pi radians is 360 degrees. Just know this. 2, I'll call it pi, rad equals 360 degrees. And so 0 degrees, 0 is 0 on either side. So 0 degrees is 0 radians. Okay. 90 degrees, well, let's go to 360 would get you to 2 pi radians. Well, half of that, 180 degrees, is therefore half of 2 pi. So this is 180 degrees, or pi radians. And if 180 degrees was pi radians, then 90 degrees is pi divided by 2 radians. See how that works? And so you can just divide up 2 pi around the circle proportionally and figure out every single radian value if you need to. I hope that helps with the trigonometry. If you have any questions, feel free to send me an email. Otherwise, take care.